Welcome to math class. Yeah, welcome to math class. Summer's over, bell is ringing. New adventures just beginning. Gonna learn and have some fun now.
If you have 30 red socks, 20 blue socks, and 10 green socks, how many would you need to blindly pick to guarantee at least one pair? If you drop a nickel off the Empire State Building, how long does it take to hit the ground? We can actually calculate that using radical equations. Hi, welcome back to math class. Glad you are joining me as today we are mastering our ability to solve radical equations involving square root and cube root functions, both algebraically and graphically. This video will cover TEKS 4F, 4G, and 6B of Algebra 2. So the big question is why do we always have to check our answers? One hint, extraneous solutions. As we are learning to master the radical equations in order to solve them, we're going to apply the four-step solution map. We're going to start at step 1, isolate the radical. That means move the radical term to one side of the equation if possible. Step 2, we're going to square or raise both sides of the equation. This is going to allow us to eliminate the radical by squaring or raising both sides to the appropriate power. If it's a square root, we are going to square. If it's a cube root, we're going to cube it. That will help us create the inverse. Step 3, we're going to simplify and solve. We're going to use standard algebraic operations to solve for the remaining variable. Step 4, check your results and verify. Extraneous solutions could occur. These are results that emerge from the calculation, but they do not work in the original equation. This step is a very critical gatekeeper. Okay, let's take a look at our first example. We're going to solve 1/3 of the square root of x plus 4 equals 5. We want to solve for x. First step is we are going to subtract 4 from both sides. Second, I'm going to multiply both sides by 3 in order to undo the 1/3. Next, I'm going to square both sides in order to undo the square root. Finally, I'm going to subtract 4 from both sides to get the final solution for x. Now we are not done. We do need to check the final answer of being x equals 5. We need to make sure that this will actually work, that it's not extraneous. So we're going to plug 5 in back into the original equation. So then I'm going to evaluate using order of operations. I'm not worried about the right side because 5 is just going to stay 5. I just want to know, does the left side equal 5 if I continue to evaluate it? So 1/3 of the square root of 5 plus 4 plus 4, does that equal 5? Our first step is to evaluate the inside of the radical. Next, we're going to evaluate the radical. Next, we're going to multiply 1/3 times 3. And finally, 1 plus 4. As you can see, we get 5, which is equal to 5. So our solution, x equals 5, is good. Okay, for example 2, we're going to solve the square root of 2x minus 5 is equal to x minus 10. The very first thing I need to do is to take the square of both sides in order to undo the square root. Okay, after squaring, I'm going to go ahead and multiply this through, FOIL it through. So we're going to get x squared minus 20x plus 100. Next, I'm going to move the 2x and the minus 5 over to the right side. So I'm going to zero out the left. So with x squared minus 22x plus 105, I'm now going to find the factors of 105. That will give me negative 22. So with our factors of x minus 15 and x minus 7, I'm now going to set each of these factors to 0 in order to solve for x. So for each of these two factors, I will now solve for x. On the left side, I have x equals 15. And on the right side, I have x equals 7. So now I need to check to make sure that these two solutions are good solutions. I should not have an extraneous solution. If it is extraneous, then I am going to reject it. So let's first check x equals 15. So as you can see, through the process, I get 5 is equal to 5, so 15 is a good solution. Next, we're going to check x equals 7. As you can see, 3 does not equal -3. So we are going to reject that second solution. Okay, our next equation is solve square root of 5x minus 7 equals the square root of 3x plus 11. The very first thing I want to do is get rid of the square root symbols. So I need to square both sides of the equations. Okay, next we're going to add 7 to both sides and subtract 3x from both sides. Then we're going to divide by 2 on both sides. So with our solution of x equals 9, we next need to check to make sure that that solution is actually good and not extraneous. So after running it through the check, we get square root of 38 is equal to the square root of 38. I think we can both or all agree that this is the exact same number. So we can say that this is a very good solution. Okay, in example 4, we're going to solve the square root of x minus 5 plus 1 is equal to the square root of x plus 2. First step is I'm going to square both sides. Okay, after squaring both sides, I am then going to FOIL the left side of the equation. I'm then going to simplify the left side of the equation a little bit further. And then I'm going to continue simplifying it just a little bit further. This one takes just a little bit longer. Okay, now that the left side is fully simplified, I'm now going to subtract x from both sides as well as add 4 to both sides. I am then going to divide both sides by 2. I am then going to take the square root, not the square root, sorry. I'm going to square both sides. And finally, I'm going to add 5 to both sides, giving me a solution of x equals 14. I now need to check that solution to make sure it is not extraneous. We have square root of 14 minus 5 plus 1, set it equal to square root of 14 plus 2, and we want to know, are they equal? Which simplifies to the square root of 9 plus 1 is equal to the square root of 16, which is 3 plus 1 equals 4, which is 4 equals 4. So x equals 14 is a good solution. Okay, in this next example, we have 5 times the cube root of x minus 1 equals 25. So the process for cube roots is identical to square roots, but instead of squaring, we're going to cube both sides. So the first step I'm going to do is I'm going to divide both sides by 5. I am then going to take the cube of both sides. In order to undo the cube root, I have to cube it. Finally, I'm going to add 1 to both sides, with the solution of x equals 126. Next, I need to check to make sure that that solution is not extraneous. Does 5 times the cube root of 126 minus 1 equal 25? That's what we need to check. On the left side, I have 5 times the cube root of 125. On the right side, it's still 25. Evaluating the cube root of 125, I get 5. And then 5 times 5 is 25. So x equals 126 is a good solution. In this final example, we have the cube root of 4x minus 1 plus 9 equals 10. First thing I'm going to do is I'm going to subtract 9 from both sides. Next, to undo the cube root, I have to cube both sides. Next, I will add 1 to both sides. Finally, I will divide both sides by 4, giving me a solution of x equals 1/2. I now need to check to make sure that this solution is not extraneous. Does the cube root of 4 times 1/2 minus 1 plus 9 equal 10? I will simplify the left side by evaluating the radicand of the cube root first. This gives me 2 minus 1 on the inside, and further simplifying, we get the cube root of 1, and the cube root of 1 is just 1 plus 9, which is then 10, and 10 is equal to 10, so x equals 1/2 is a good solution. On our next example, we're going to solve the square root of x minus 10 plus 4 equals 5 graphically. Now, we could actually solve this one algebraically, and this is what we would end up with here. We would get x equals 11, and after checking, you would see that it's still a good solution. But we can actually solve any equation by looking for where the two functions intersect each other on the graph. So what we're going to do is we're going to take the same function, and we're going to set the left side as one function and the right side as another function in Desmos. And then we're going to find the points of intersection, and the x values of those points are your solutions. So after plugging it into Desmos, I had the left side of the equation as my f of x function. So f of x equals the square root of x minus 10 plus 4. That is going to be this red line. The blue line is my g of x equals 5. I take the right side and I make it its own function. The intersection is at 11, 5. The x value is the solution, which is actually confirming what we just found when we were solving it algebraically. So the graphical method is great for verifying your algebraic work, especially when you're checking for those tricky extraneous solutions. Okay, so let's bring it back to our situation from the very beginning where we talked about a nickel falling off of the Empire State Building. But instead of an Empire State Building, let's make it a table instead. So we're going to use the following formula to represent the situation. T equals the square root of h sub 0 minus h divided by 4.9, where t represents time, h is when the nickel hits the ground, so h will equal 0. So in this scenario, we're going to let t equal 1.5 seconds, and we're going to find h sub 0, which represents the height of the table. So in our function, we have 1.5 equals the square root of h sub 0 minus 0, all of that divided by 4.9. First thing I'm going to do is I'm going to go ahead and get rid of the minus 0 because you're subtracting 0 from h sub 0. It's just h sub 0. And then we're also going to multiply both sides by 4.9. So the square root of h sub 0 is equal to 7.35. I will now square both sides in order to undo the square root, where h sub 0 is equal to 54.0225. H sub 0 again represents the height of the table. I did not specify the units, so let's call these centimeters. So the height of the table is 54.0 centimeters. And if I was to convert this to inches, I would just take 54 divided by 2.54. where h sub 0 would then be 21.3 inches. All right, to recap, we've covered the 4-step algebraic process, the difference between squaring and cubing, and how to find solutions on a graph. So the final reminder is just never skip step 4. You always check your answers in the original equation to catch extraneous solutions. So as always, thank you for watching. If you found this video helpful, please be sure to smash that like button and subscribe to my channel to be notified when new content appears. Thank you. Class dismissed.